Okay, so here's the first example for today. We need to evaluate the following limit. Evaluate the limit of f of x. Actually, yeah, we can write it this way when x goes to infinity. And f of x is the function, we have a square root on top, 2x squared plus 1, divided by 3x minus 5. This is a slightly modified from the original question. The original question asked for horizontal and vertical asymptote of this function, which is one of the things that we already established, that the horizontal asymptote will be the limit when x approaches either positive or negative infinity. So by answering this, by evaluating this limit, we're basically going to evaluate, we're going to find out the horizontal asymptote, the value of y when x goes to positive or negative infinity. And to answer the other question that I didn't ask here, what is the vertical asymptote? Well, the vertical asymptote will be the zero of the denominator. So we're going to set 3x minus 5 equals 0 and x equals 5 over 3. And this will give us the vertical asymptote. So in this case, I'm going to ask you just to evaluate. And so here's how we approach this problem. The limit as x approaches infinity of the square root. Let's rewrite this problem. The square root of 2x squared plus 1 divided by 3x minus 5. So the first step is the following. I'm going to try to factor out x squared from the numerator. Okay, so I'll do it slowly. Sometimes I have a tendency to skip steps here, but I'll hold myself from doing it so. So I'm going to factor x squared, and of course I have 2, but then the other term will be 1 over x squared. And you can see immediately where I'm heading. Well, I'm heading so that the the square root of a product is the product of the square root. We have this distributive property of the square root, and the square root of x squared, of course, is x. So I can factor out the x, and I'll do the same thing in a bit. In the next step, I'll do the same thing with the denominator. So here comes the next step. The limit as x approaches infinity. As I said before, now I'm going to distribute the square root, and the square root of x squared is x. So I'll have x times the square root of 2 plus 1 over x squared, like so. And I'll factor x from the denominator. So I have x times 3 minus 5 over x. Okay? Now, you can see that this is really a favorable way to write it, because the limit of 1 over x squared is 0, as well as the limit of 5 over x, because we are using the fact that the limit of 1 over x to the power of r is 0. So x, of course, are being reduced. And now, applying the limit laws, first of all, the limit of the quotient law. So we have the limit as x approaches infinity of the square root of 2 plus 1 over x squared divided by the limit as x approaches infinity of 3 minus 5 over x, like so. Okay, so this is quotient law. I'm kind of debating whether to write the law. Yeah, why not? Let's write the quotient. Okay. The next thing I'll do is apply the root law. Remember, the limit of a root of a function is the root of the limit of the function. So the numerator, we can take out the root and say this is the same as the root of the limit as x goes to infinity, and now we have to worry about only the limit of 2 plus 1 over x squared. Okay? Over the limit of when x goes to infinity of 3 minus 5 over x. So the step here, we use the root law as applied to the numerator. Now, what I'll do next is, let me ask your advice or guidance. What will be the next step? What do you see in this limit?
Can we substitute 0 for 1 over x?
Not yet, not yet. Before we do that, formally, sum and difference, right? And then we do the substitution. Remember, we are working formally here. If it was informally, I would go ahead from here, I'll substitute right there and say, okay, this is square root of 2 over 3, right? But formally, I need to invoke the sum rule, so it will be the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 1 over x squared. And now I can use this property. And then in the denominator I'll do the same thing. So it will be the limit as x approaches infinity of 3 minus the limit as x approaches infinity of 5 over x, like so. So here we use sum slash difference. Okay? Now we can use the substitution. I wonder if I can squeeze it into this line. Nah, we have plenty of paper, so let's move to the next page. So we write. Now I'll do the substitution, and I have the square root of 2 plus 0, limit of 1 over x squared, divided by 3 minus 0. And again, this is substitution. Substitution that include also the property of the limit of 1 over x to the power of r. And we end up having the result of the limit would be square root of 2 over 3. Okay. So this is a step-by-step procedure. No shortcut here, I think. And if asked to show all your calculation steps in the test, this is how you need to write.